Okay, now in this section we're going to begin exploring some trig identities. So let's go over the ones that we know first. So we just did the negative angle identities, which would be looking at them as even and odd functions. So we saw that sine of negative theta is equal to negative sine theta. Cosine of negative theta is equal to cosine theta. And tangent of negative theta is equal to negative tangent of theta. And then, of course, if you needed cosecant, secant, and cotangent, they would go with those. Okay, and then we also have the reciprocal identities, so that would be cosecant of theta is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tangent. Alright, and then we also have our Pythagorean identities. So that's where we start with sine squared plus cosine squared is equal to 1. So that one we've seen a number of times. That comes directly off the unit circle. And then we can change this into a couple of others by dividing through by sine squared or dividing through by cosine squared. So if we divide through by sine squared, we would have 1 plus cotangent squared theta equals, and then 1 over sine squared would be cosecant squared theta. Okay, and if we go back to the original, we divide through by cosine squared, we would have tangent squared plus 1 equals secant squared. Okay, so if you can remember the first one, you can remember all three. Just divide through by sine squared and cosine squared and get the reciprocal functions. And of course, you've got all the variations of these. So for example, you could make this sine squared is equal to 1 minus cosine squared if you wanted to move the cosine squared to the other side, or you can move the sine squared to the other side. So you can rearrange these as well, and they're still considered the Pythagorean identities. So if you see like a tangent squared in a problem, you might want to come over here and say, okay, I know that tangent squared is equal to secant squared minus 1, and see if that helps you. Okay, so you've got all the different variations of these as well. So while you're getting used to these, you may want to have these written down nearby so you have them to refer to, but eventually you'll get pretty used to using them. Okay, so let's look at how we can use these identities. Let's say that the directions are to simplify something. We've got, let's say, cotangent theta sine theta, and we want to simplify this. So when you look at this, see if it's something that you can, one of the ones that we could use before, like Pythagorean identities or negative angle. If nothing pops out at you directly, then try switching everything to sine and cosine. So we can use our reciprocal identity that this is 1 over tangent, or we can remember that it's cosine theta over sine theta, which would be the reciprocal of tangent. And then when we do that, now we see that the sines can cancel, and this is actually just the same as cosine theta. Okay, so for a lot of these, it's just kind of playing around with them, using those identities from before, and if you don't see something obvious, then change them to sine and cosine and see what you can do about getting things to cancel out. Okay, now for verifying identities, here are some kind of unwritten rules to go by. The first and most important one is that you can only work one side at a time. You do not want to do operations to both sides. So you don't want to add sine to both sides or subtract 1 from both sides. That would be kind of considered in bad form as far as proofs go. So you can only work with one side at a time. Now, in one step, you could change the left side and the right side as long as you're working with them separately. Okay, so you need to get one side to match the other side. Look for the fundamental identities that we talked about in the first video. Try to rewrite the more complicated side first. Sometimes when you start working with that, you kind of see how to get to the other side. Look for factoring, common denominators, or other operations like maybe squaring something out or combining fractions, things like that. If you have 1 plus sine, try multiplying by 1 minus sine over 1 minus sine. That's 1, so you're not changing anything. That'll give you 1 minus sine squared because of the difference of 2 squares. And then that, is equal to cosine squared. Oops. So that gives you something to work with there. And then same thing for cosine. If you have 1 plus cosine x, try 1 minus cosine x over 1 minus cosine x. That'll give you 1 minus cosine squared, and that's sine squared. Whoops. Sorry, we're doing x, not theta. And then the same thing, if you have 1 minus sine, you do 1 plus sine, 1 plus sine. If you have 1 minus cosine, you do 1 plus cosine over 1 plus cosine. So that's just a hint, because there's really not much you can do with just a plain sine or cosine if it's being added to something. So that's kind of a trick that you can use with the difference of two squares to get into something that you can simplify. If nothing's obvious from what you're looking at, try rewriting everything as sine and cosine. Sometimes those reciprocal functions will start to cancel out, or you may just see better where you need to be, like what the denominator needs to be, or something like that. And then finally, if something isn't working, just start over. Sometimes you can make a small mistake at the beginning, or maybe you're trying to force it into like a Pythagorean identity and it's not. So sometimes you just have to start over and look at it with fresh eyes and try to work it through from there. Maybe a different way, or maybe you'll see a mistake that you made as you went through. But if it just keeps getting worse and worse, especially for the ones that we're doing, they're not going to be that bad. If it keeps getting worse and worse, then probably it's time to just put that aside and start over and see if maybe you can find a different method. Okay, so let's go ahead and try one. Let's say that we want to verify that sine alpha plus cosine alpha cotangent alpha is equal to cosecant alpha. Okay, so we want to verify this. That means that we need to get the two sides to match. We've got to show that they're equal. So let's start with the more complicated side. That's the stuff on the left. Can't put these two directly together, so let's try to see if we can simplify this. So let's leave sine alpha alone. Let's change cotangent into cosine over sine and see if that helps us. And I'm just going to leave cosecant alpha hanging out over here on the right. Okay, so now what do we have? We multiply the numerators, and we've got cosine squared alpha over sine alpha. Okay, so that's not doing too much for us yet, but if we get a common denominator, maybe we can put this together and see something else. So to get a common denominator, we've got to multiply this one by sine alpha over sine alpha. And that's going to give us sine squared alpha over sine alpha. And here we've got cosine squared alpha over sine alpha. And you should maybe start seeing where this is going now. We've got a common denominator. We put these together. Sine squared alpha plus cosine squared alpha over sine alpha, and cosecant alpha. And remember, sine squared plus cosine squared, this whole thing is equal to 1. So I kind of ran out of room here. We're going to go this way with it. So I've got 1 over sine alpha equals cosecant alpha, and that's one that we definitely know is true. That's our reciprocal identity. And so we've gotten to the end. If you want to, you can write cosecant alpha equals cosecant alpha. That's fine too. But this is enough to see right here that it's the same thing. Okay, so that's the basic idea. Just take one side and start simplifying it. If you need to, you could rewrite this as 1 over sine, and maybe that would kind of help you see where you're going. But this one, we just kind of went with what we knew, and we saw that we got to where we needed to be. Okay, so don't be afraid to play around with them a little bit if you're not seeing right away where you need to go with it. Just try playing around with some things and see if it works out. And if it doesn't work, go back and start over.